Hello. Hello. So, welcome and good day. Now that we have covered the Pythagorean Theorem and, of course, the use of trigonometry in determining the direction of the vector, we are now ready to delve into a more complex form of resolving vectors, which is known as component method. So, as a review, before we use this example, typically we have the x and y axis, right, of a Cartesian coordinate system, correct? So let me just draw this, right? So if we draw a certain vector starting from the origin, okay, so let's take this one. Let's say this is my vector, okay, or let's just use straight line. Array, let's say this is array. So there. So let's denote this vector R. So you can see it has two components, right? Components, if you remember in math, you can describe it by its coordinates, right? So let's say its x component or x coordinate is this long, right? Because as you can see, let's try to draw some mark like this. So there, so this is its x component, so we're gonna call this r sub x, okay? And then for the y component, actually let's just try to complete the y-axis first. Okay, so our y component will be this line. Okay, so I'm gonna use this color, which is now r sub y. So this is our y component. So typically in math, we try to describe this particular line as, or actually the particular point, the point here, as a coordinate, right? Coordinate, or what's the other term? Pair. I forgot the exact term. The abscissa and the ordinate, those two numbers. So for this one, you have, well, this value, let's say it's an x, then the value of this is, let's say, a y, right? So something like that. So in physics, what we want when we're determining the components of a particular vector is determine really the x and the y component of that particular line. Something like that. Okay, so let's try to read the example here. So this is the third guided practice problem. Okay, so the scouts are on a hike. Starting from home base, they made the following movement. So what we are tasked to do is determine the magnitude and the direction of force. So I have prepared the problem already, which is this. Okay, so if you're going to read, so the first given is 2 kilometers 40 degrees north of west. So if you're going to take a look, this is the line. For the second one, we have, or vector B, we have 4 kilometers 18 degrees west of south. So it is this one, the blue line. And then for the third one, we have vector C at 3 kilometers 28 degrees south of west. So this violet line. Okay, so breaking it down, let's try to break it down. And I'm not gonna be as precise on this one. I just want for you to see that what we are talking about on the angles and how we are going to convert them into, well, you can convert them at this point already, you may not, it's up to you, but I'm going to do both. Okay, so and then we're going to look at our final answer if we're going to arrive at the same one. So for this first one, we have 40 degrees north of west. So as per the review, if you watched it, you're going to start from the western direction. So that's from here. This is west, right? So that's 180 degrees. Okay, so you're going to turn 40 degrees going to the north. If you're going to read the grammar north of west, it means starting from the west side, you're moving northward. So how much? How many degrees? 40 degrees. So we're going to do that like this. Okay, so we're going to denote it with, of course, a white line since our vector A is white, right? So let's do it. Or let's change the thickness like this. There. I'm not gonna be too precise on this, okay? As long as you can see. So now, since this is 40 degrees and it is rotating on which direction? It is rotating on a clockwise direction, right? Like this. Since it's starting from the west. Alright, then going to this direction. Something like that. So according to the review, what we want to do is, of course, we can leave it as that or we can convert it. So we can have the angle that has a reference line at 0 degrees or at positive x-axis. So let's have that. Okay, so starting from 180 degrees minus 40. Okay, so I'm going to say that this angle is alpha. Okay, so our alpha is gonna be 120. Or I mean 140, sorry. 140 degrees. There. So this is our first vector. So let's go for the second vector, vector B. I hope we can fit all of this here, this space. Well, if we can't, we're just gonna move the... Actually, let's do that now. Let's try to move the diagram. Oops. Let's try to move this. Again. There, we must include everything. There. Okay, so let's continue doing this. So for B, we have the Cartesian plane. There, so it is 4 kilometers, 18 degrees west of south. So we're going to start from the south. Okay, moving to the west. So let's try to take a look. So if this is south, moving to the west, so in this direction. Okay, so it's just 18 degrees. Oh, wait. West of south. Oh, yeah. It's correct. West of south. So 18 degrees is just very small. So we're gonna turn very slowly like this. And we're gonna use blue to draw our vector. It doesn't look like an arrow. There. Okay. Oh, you know this is an arrow, okay? So then we have our vector. So I'm gonna name this beta. All right, so our beta is starting from the south. So south is what? 270, right? So that's 270 minus 18. All right, so our beta has a value of, so this is the angle for vector B. All right, so this is 2765, 258 degrees, or I mean 252 degrees there. So by using this, at least we don't have to what do you call this? We don't have to utilize the direction in here anymore. Okay, so let's double check. I just want to be very sure. It's minus because the direction of the turn is again there. Direction of the turn is again clockwise, right? So this is clockwise. Oops. So like this. For the second given, it is clockwise again, as you can see. Okay, so let's now have vector C. So this is our Cartesian plane for vector C. So this is 3 kilometers, 28 degrees south of west. Okay, so we're going to start from west, going to the south. Okay, so this is our west, going to the south. So it's the reverse of what we did earlier. All right, so it's going to this direction. Okay, so this time it will be counterclockwise. So 28 degrees is a bit bigger than 18. So something like this. Let's change the thickness and there. So now this is our new, or I mean the reformed, in a sense, angle. So what we want to do is to again have our reference line starting from the positive x-axis, which is here. Okay, so all of the angles here are changed so that let's denote it using a red line or a red marker. So going to this direction. Okay, then for this one it's like this. Okay, then for this one it's like this. Okay, so for this one we have gamma. I'm going to use gamma. So this is 28. So since it is counterclockwise, it is gonna be addition. Okay, so this is 180 degrees is starting from the west, right? West is 180 degrees plus 28. Okay, so our gamma is 208. All right, so far so good, hopefully. There. So okay, so first I'm going to try to solve using the angle at the given. Okay, and then for the second example we're going to use this the true angles, so I call them. Okay, so for the equation, of course we're going to find the r sub x and r sub y. So it will be Pythagorean. Okay, but first we're going to add up the values of a sub x, b sub x, and c sub x, and then a sub y, b sub y, and c sub y. So, sir, how are we going to do that? So, for r sub x, it's gonna be a sub x plus b sub x plus c sub x, okay? And then for r sub y, it's gonna be a sub y plus b sub y plus c sub y, okay? There. So this will be our first table. So for the column header, we're gonna have r sub x, and then for this one, we're gonna have r sub y. For our column head, well, this is row header. For column header, we're going to have, of course, vector A. Then, of course, we have vector B. Let's have columns for this as well. So this is vector B. Then we have vector C. This is for vector C. Then finally, of course, our total or the sum. Okay, so I'm just gonna put a summation sign on this. So hopefully you know that already. So for r sub x, remembering your trigonometric lessons before, the trigonometric functions we use for x is cosine. Okay, so this will use the trigonometric function cosine, and then of course for this one it's gonna use the trigonometric function sine. Okay, so how are we going to do that? So to determine a sub x, we're gonna have a cosine theta. Okay, so for this solution, I'm going to show you two ways of doing it. So the first one is utilizing this given. Okay, we're going to do that and how we're gonna use it. And then for the second one, of course, we're gonna use this. Okay, so you could see what's the better approach for you. So for the first one, I'm going to have a sub x, of course, is equal to, so what's the value of vector A? So vector A is 2 kilometers. Okay, for this one, you can just remove the unit. Well, for the table, you can remove the unit. Okay, I'm gonna be forgiving of that. So for this one, it will be cosine 40. Okay, so let's input that on our cycle. So we have 2 cosine 40. Okay, so the value is 1.5321. So at least 4 decimal places. Okay, so that if we arrive at the final answer and we round it off to the nearest 2 decimal places, we wouldn't have so much worry. All right, on our final answer. Okay, so is this the final? No, it's not. It's not. Well, not yet. Okay, so now you take a look at the what do you call this, direction that's referring to the x-axis. So for vector A, that's west. So do you still remember what's the sign of west? So west is negative x, right? So since it is negative x, you're going to put a negative sign on this. Okay, you see that? All right, so let's repeat the process. For this time, we're gonna have to answer the sign. Okay, 40 there. So I'm going to write it. So a sub y is equal to vector A sine, well, in this case it is alpha. Okay, let's change this because the angle that we're using is alpha, the one that is on the given. Okay, so for this one, this is a sub y, this is 20, I mean 2, sorry, 2 sine 40. Okay, so this is our answer. So that's a sub y is equal to 1.2856. Alright, so now let's take a look at our given and look at the direction referring to the y-axis or denoting the y-axis. So in this case, we have north. Okay, so north is what? Positive y, right? It's north or positive y. So it means the sign of our a sub y is gonna be positive. Okay, so of course you don't have to write that. You can just leave it like that. Okay, so that's the first one. So sir, how about if we're going to use the other way? Okay, so I'm gonna try to do that. Let's see if we can fit it here. I'm just gonna show you, okay? Because personally, I prefer using this other one. Okay, so I think I need to write smaller, so I'm gonna change my pen size. So for this one, it's gonna be 2 cosine 140. Okay, 2 cosine 140. There. So let's try to solve that. 2 cosine 140. There. Can you see? It's automatically written as 15321. See? It's automatically written as the negative sign without actually trying to look back on these values. Okay? So how about we try it on this one? So this will be 2 sine 140. The equal sign is already written on the left side. That's why I'm not writing it. But if we're going to utilize this fully, of course you write it properly. So it's gonna be, let's say, a sub x is equal to 2 cosine 140. Something like that. Okay? That's because the space is kind of small na. And additionally, I want to say, well, let's do it properly here on B. Okay, so for this one, it's gonna be 2 sine 140. There. So as you can see, the answer is the same, 1.2856. All right. So let's try to divide this evenly. So usually when we're, let's say, take a look at example A. Okay, so example A, the triangle of this looks like this, right? Well, let's try to draw the right angle first. There. Then here is the angle. That's why it's easy to do the trigonometric ratio because it's oriented at the right place. So this is of course the opposite, then this is the adjacent side. Okay, in the case of vector B, the triangle is like this. The angle is located here. So of course the opposite side is the x-axis instead of the y-axis and vice versa. That's why what we're going to do on our solution is, in the case of b sub x, the trigonometric function that we're going to use is sine, and the trigonometric function that we're going to use for b sub y is cosine. Okay, so it's a bit tedious and you have to remember that. That's why I recommend using this one instead, which is I'm gonna show you after this example. So I'm gonna speed things up from here and then I'm gonna return explaining later after I'm finished. Okay, so take a look. So our answer for b sub x is negative 1.2361 since the direction is west. Okay. And then for b sub y, we have negative 3.8042 since the direction on the y-axis is south. Okay, so take a look here, and I'm going to use the true angle, which is this. So we don't have to remember any unnecessary step. We're just gonna input the values on the cycle and poof, that's it. So take a look. So this will be 4 cosine 252. Okay, so I'm gonna input that here. So this is 4 cosine 252. So see, the answer is automatically negative 1.2361. Then we have 4 sine 252. And our answer is negative. So this is 4 sine 252. Our answer is negative 3.8042. So hopefully you got that. Okay, so for vector C, our triangle looks like this. So here's the angle. Here's the angle. So the correlation is still correct. So this is the opposite side, and then this is the adjacent side, which is of course the correct orientation, because the angle is originating from the x-axis. But of course, we're going to do both methods, so doesn't matter as much. There. So a bit tedious. Yeah, very. But of course, it's gonna be worth it. So on our equation, after accomplishing this, so we have r sub x. Well, this is, I'm gonna write it like this. So b sub x, then c sub x, addition. So it's gonna be r sub x. So we could fit it properly. Okay, so for r sub y, we're gonna have a sub y, b sub y, and then c sub y. Then you add this, you have r sub y. Okay, so of course, after accomplishing that, I'm just gonna move this down. So I'm just gonna copy our vector. So for r sub x, we have negative 1.532. Okay, plus, where is it? Negative 1.2361. Okay, plus, where's the last one here? Negative 2.6489. There. So our r sub x is gonna be equal to, okay, let's try to add. So in this case, after arriving at this point, you may now return the unit. Okay, but first let's try to add negative 1.5321. Okay, minus 1.2361 minus 2.6489. Right, it's gonna be the same as let's say you want to place parentheses here. Then this is gonna be add. It's gonna be the same. Okay, then let's say you want to add parentheses here. Okay, then this is add. It's gonna be the same. Okay, so our answer is negative 5.4171. Our unit is of course in kilometers. Then for r sub y, we have 1.2856 plus negative 3.8042 plus negative 1.4084. Then our answer here will be, okay, let's find that. So we have 1.2856 plus, well, I'm just gonna use minus, okay, 3.8042 minus 1.4084. There. So our answer is, well, let's double check. Negative 3.927 kilometers. Okay, let's try to check if we have answered 3.8042. 6, 8, 2, 4, 2, 4, 8, 9, 2, 3, 6, 1, 1, 5, 2, 8, 5, 6, 8, 0, 4, 2. Okay, 8, 0, 4, 2, then 1, 4, 0, 8, 4. Alright, so now that we have arrived here, let's return to our equation portion. This is already under solution, right? So you can just like denote that. Okay. So what we need is of course the value of r. So this can be resolved by doing now the Pythagorean Theorem. So by this point, this is already the step that you are very familiar with. So let's proceed on doing that. So we have vector r is equal to negative 5.4171. If you remember the distance formula, this is basically it. Okay, plus negative 3.927 kilometers squared. Then we're going to place it under the square root sign. There. So we can now input this on our cycle. Okay, so finally we have our answer for the magnitude. Okay, so because after this it's already the final answer, so oops, we place negative 5.4171 to be squared. Oops, here. Okay, then we have plus parenthesis again. This is negative. Oh, we place it here. Negative 3.927. Of course, this is to be squared. Okay, then we just delete the unnecessary. I think we have unnecessary accuracy there. So our final answer is 6 point. Well, at this point, you can now write it as. You can now write it as, or I mean, round it off to 2 decimal places. So there's your answer. So you have 6.69 kilometers squared. So you can show the cancellation of units by squaring this and of course squaring your values. Then squaring this and squaring your values. Okay, so this is cancelled, of course. then this is cancelled. So you're going to, of course, square root your numbers. Okay? So, and this is not squared there because it's just a linear unit. Okay? So looking back at your diagram, you can see that it kind of makes sense. Okay? That the answer is, well, really longer compared to our longest vector, which is 4 kilometers. So our vector r, or the resultant vector, has a value of 6.69 kilometers. Now let's proceed on finding the, finally, we're going to look for the theta. Okay? So for theta, so this is just basically tangent inverse, okay, r sub y over r sub x. Okay, so if we're going to take our triangle there, so this one, let's try to copy it. I will be able to copy it. So if you take a look at our diagram, I'm going to draw hard lines, hard yellow lines. There. So as you can see, this is r sub x, then this is r sub y. The angle is located here. Sir, how are you able to say that the angle is located there? Well, if you're going to take a look at our first vector, which is this is vector A, right? This line. So as you can see, this is the location of, well, the vector, or I mean the angle is located between the arrow tail of the first vector and the arrow tail of the resultant vector. It will somehow should be located there. Okay, so I'm going to show it through solution if we're going to arrive at the same conclusion. After all, physics is a scientific process, right? So let's leave it at that and let's try to solve. Okay, so this is tangent inverse. What's our r sub y? Let's go back to our previous solution. R sub y is negative 3.927 kilometers. Then for r sub x, we have negative 5.417 kilometers. There. So let's cancel the units. Then we input it on our cycle. We have tangent inverse here. So then we want fraction. So this is negative 3 point. Actually, you can cancel the negative sign here. There. So we're just going to write positive number. So this is gonna be 3.927. Then our denominator is gonna be 5.417. 417. There. So what's our answer? So our answer is 31. I mean 35.94. Now, taking a look at your diagram, okay, so sir, how did it come that our answer is located at the third quadrant, or I mean the vector is located at the third quadrant, but our final answer is located at supposed to be the first quadrant? So the explanation for this is, if we're going to complete the Cartesian plane, so I'm going to use a different colored pen. Let's try orange. Okay, I'm going to draw the extension of this angle. Okay, so you could see. See, even our measurement on our makeup ruler / protractor is almost very close. Okay, so I'm going to draw this. Then I'm going to draw its triangle. Okay, see, and of course our angle is located here. So if this is the case, wait, it's a bit big. So if this is the case, of course, our answer will be correct. But this will be correct if this is math. But of course, this is physics. So we want to abide on the proper presentation. So we can approach it in two ways, knowing that the true direction of the turn of the angle or the rotation of the angle is from the x-axis going to where the angle is located. Okay, so in the same case, it's our resultant vector turns like this, starting from the x-axis going to the location of the angle. Okay, so since r sub x in this case, okay, if this is our Cartesian plane, okay, I'm going to draw an imaginary Cartesian plane here. Okay, so if this is our Cartesian plane, so you can see r sub x is located at the negative x, okay, or 180 degrees. This is 180, this is 270, this is 90. Okay, so since the rotation is counterclockwise, what we need to do is just add to find the exact angle that is being referred by our illustration. So this is 35.9 plus 180. Okay, so our final answer is gonna be, let's have 35.94 plus 180. There, so our answer is 215.94 degrees. So you can answer that. So it will be consistent on our other solution. Or if you want to implore our learning, you can just utilize the directions. Okay, so this answer is correct. Okay. Okay, so this answer is correct. It's fine. Okay, or you can have 35.94. So starting from the west going to the south. So that is southwest. Okay, so this answer is correct as well. Okay, so for your final answer, you can have our resultant vector is equal to 6.69 kilometers with 35.94 degrees south of west, or 6.69 kilometers, 215.94 degrees. There. So it's a bit long, especially because of the table. But after you have resolved this and you made sure that it is correct, it will be guaranteed that this will be correct as well. Okay, so I'm going to have another example, but in that case, it will not have a voice, just like the first one. Okay, and then you can just watch it if you want more examples. If not, you can proceed on answering the self-paced practice problem. Okay, so thank you and may you all have a good day.